So let's look now at the factor and remainder theorems. And what we're going to do in this lesson is we're going to learn about the remainder theorem and then the factor theorem and how it applies to polynomials. Now, the remainder theorem is a new theorem, and this theorem tells us this. When a polynomial p of x is divided by a binomial in the form x minus a, the remainder is p of a. Now, what does that mean? We take any polynomial p of x and we divide it by a binomial, x minus a. The remainder can be found by taking that a value and putting it in to the polynomial. And the number that you get out is the remainder. And that's the remainder theorem. Now the a, much like we did the zeros, remember the a is going to be the opposite of that value. So if we had a x minus 3 as our x minus a as our binomial, then we would put the number 3 into the original polynomial and we would get out the r value. That's the remainder theorem. So let's apply this remainder theorem because here is our polynomial p of x and we're dividing it by x plus 1. So our a value, or our 0, however you want to think about it, is negative 1. So all we have to do is take our polynomial and put in a negative 1. Well, pretty easy to do. Just put negative 1 in for x. Just watch the sign, and it's very important when you have positive and negatives. And when we do the calculation, that will give us the remainder. So negative 1 cubed is negative 1 times 3. This becomes negative 3. Negative 1 squared is 1 times negative 5. We get a negative 5. A minus 15 and a minus 9. And when we combine all our values together, we get negative 32. And the remainder theorem is a quick way to find the value of the remainder. Now we may use the remainder theorem just to find the remainder. We may also use it like in a situation like this. We're given the remainder. Again, here is our polynomial. This time it's p of y, and the a value we're going to put in, the y value is 2. Now we're told that the remainder is 1. So when we put p of 2, put 2 in for y, we know we're going to get 1. That's going to help us find this k value. Because if we were to put that value in of 2 into the actual polynomial, we would get 4 times 2 cubed minus k times 2 squared plus 3 times 2 minus 1. And we know that that polynomial is equal to 1. So we can combine these two pieces together and write it like this. 1 equals, well, figure out the number. 4 times 8, 2 cubed is 8, is 32, minus 4k, plus 6, minus 1. And that then allows us just to do some simple algebra. And we get 1 on this side. Add our values up here, we get 37 minus 4k. Bringing the 37 to the other side, we get negative 36 equals negative 4k. Divide both sides by negative 4, and it's pretty easy to find a k value equal to 9. So sometimes the remainder theorem helps us find the actual remainder. Sometimes we're given the remainder, and we have to find an unknown variable. Well, an extension of the remainder theorem is what's called the factor theorem. And the factor theorem looks very similar. When a polynomial p of x has a factor now of x minus a, this is true if and only if p of a is equal to 0. What is this really saying? That the remainder is 0. So the factor theorem is really just an extension of the remainder theorem. This time we want the remainder to equal 0. So let's apply this to our question. The question is x minus 1 a factor of this polynomial? And if it is, when we put 1 into our polynomial, we must get 0. And really, that's the question we need to figure out. Is p of 1 equal to 0? If it is, it's a factor. If it's any other number, then it's not a factor. Well, just like we did with the remainder theorem before, put p of 1 in. P of 1 will be 1 cubed minus 3 times 1 squared minus 1 plus 3. We can expand this out. We get 1 minus 3 minus 1 plus 3. And indeed, when we add it all together, we get 0. So what that tells us is x minus 1 is a factor. And if we were doing the factoring, we often write the factors with brackets, and that's going to help us factor polynomials that have higher degrees. Well, let's look at this if we don't have it in that exact form. We're trying to find out now, is 2x plus 1 a factor? And remember, the factor theorem tells us it needs to be in a form x minus a. So really what we have to do here is just take this factor, and if we just take the factor, divide both sides by 2, we can really consider this as x plus 1/2. Is that a factor? And if it is a factor, that means when we put negative 1/2 into the polynomial, we'll get 0. So it's the exact same idea, only this time we have to work with fractions, and in this case, a negative fraction. So all the x's get replaced with negative 1/2. And once we have it all replaced, now we just have to work out the calculations to find out what the value is. Well, this first one is going to become 8 times negative 1/8 plus 6 times 1/4, watch your positives and negatives, minus 9 over 2 minus 5, which of course is going to become negative 1 plus 6 over 4 minus 9 over 2 minus 5. If we create a common denominator of 2, we'll get negative 2 over 2 plus 3 over 2 minus 9 over 2 minus 10 over 2. And in the end, we'll get some number over 2. More importantly, we're only concerned about is it a 0, but if we do these calculations, we can see that we actually get negative 19 over 2, which is not equal to 0. So we can say without a doubt this is not a factor. And that's the application of the remainder theorem to find factors. And we're going to do more details of this in class.